Welcome. I expect you to get and understand most of this information from the Desmos activity, but in case you need a refresher or you want to see it here, I'm going to run through this first page quickly. So really, as we're looking here at shifting a sine curve up and down, you can see here that from here to here, it just shifts up 3.5. So we take our sine function and add 3.5 to it. This one shifts down 4, so we just take our sine function and subtract 4. Okay. Now, this is called a phase shift. Sometimes we call it a horizontal shift, but with trig functions, we often call it a phase shift. You can see this in two different ways. So this is a sine function. How do we get from this gray function to this green function? I'm guessing most of you will see this as moving left, pi over 2. Remember, we always do it kind of backwards, so to speak. So inside it's plus pi over 2. Now, some of you might have thought, hey, it's going to the right 1.5 pi or 3 pi over 2. And if you did that, you could also graph it using this equation, x minus 3 pi over 2. That would work as well. Stretching and shrinking, if we do this vertically, okay, this is called the amplitude. So the amplitude for, well, let's take a look. So cosine here is the gray function. The green function here, you can see its amplitude is 1.5. This distance here is 1.5. And so that just goes out front, and that's a vertical stretch. If you look at this red function, you can see the red function has flipped over. See the gray function here, if we reflect it across the x-axis. So we're going to need to make that negative, and the amplitude's 2. So you can see for that equation, we're going to put a negative 2 in there. The last one I'm going to call horizontal stretch, shrink. We've already done this briefly in previous sections with other functions. But with trig functions, we call it a period instead of a horizontal stretch and shrink. And so you can see here with y equals sine of x, the period is 2 pi. If you look here, the gray sine function here, you can see the period. The period is where it starts to repeat itself. So if I start here until I get back to start that function again, you can see I'm going to have another period. So this is one time around the unit circle, one period. Here's the next period, another time around the unit circle. And so this green function, you can see it's really stretched out. It's got a, what I would call is a vertical stretch. Sorry, that's not what I meant. A horizontal stretch. So it stretches out. And how does it compare? This green one is actually twice as long as the gray one. Do you see that? From 0 to 2 pi, now it's stretched out 4 pi. To get from here to here is going to be 4 pi units. 2 pi here, 2 pi here. And so it's twice as long. So B ends up being half as much. So instead of having just 1, we put 1/2 in there. You can also think of this using a little formula. So you can see here, the period is always equal to 2 pi divided by b. And if we solve around, multiply by b and divide by pi, we get b is equal to 2 pi over b. B is equal to 2 pi over p. And so here, I mentioned to you that the period was 4 pi. You plug in 4 pi and you see b is 1/2. So you can think about it more logically and reason out that it's going to be 1/2, or you can use the formula here. Either way, that gives you kind of a summary of how to shift and